Good morning, Matti.
Good morning.
How are you today?
I'm just perfect, thanks.
Great. It's good to hear that you're perfect, even though I happen to know you've been doing some home renovations for the past few months.
That is correct.
Has it been intense? It's been intense?
Yes.
Okay. What's the worst part?
I think the worst part is so that, this has been ongoing for some months already. And when you work from elsewhere than home and you need to have that substitute place where you actually can live, but it's not like your home, and then working from there to the office and so forth, being entrepreneur, that's quite tense.
You have a lot going on anyway, and then having to go from place to place is probably a bit of a hassle.
Yes.
But I suspect there's some good stuff coming with the renovation as well. And one of them for you, I can imagine, would be, well, here in this podcast, we talk a lot about industrial decarbonization.
Correct.
And industrial tech and innovations. Is there anything that you're bringing into your home now with this renovation?
Yes, related to energy efficiency. In Finland, it's quite natural that when somebody renovates their home, you add some insulation, you replace some old ones, and then you have perhaps better heating systems so that they are more energy efficient and so forth. So that is of course a natural part of this renovation. But also I'm bringing in there quite a lot of new tech, like IT and audio elements, so that we have a multi-room system there and so forth. So that is something that I do look forward to.
And you listen to quite a lot of music, right?
Yeah, well, I need to have something on the background. So sometimes when you're on the mood, so that you just want to be silent and listen to the music, that is something. But also when you work or when you are making food or doing some chorals or something like that one, then that's natural part that you have something there on the background.
Is there anything specific or any type of music that you want to have in the background when you're working?
Well, I am a Bruce Springsteen fan, for example. But that kind of music and all that comes with a similar genre. But then it depends quite a lot of that. What is your mood? So that sometimes you want to listen to some jazz, and sometimes something different. It varies.
Good. So maybe next time when you're doing the dishes in your newly renovated home, you can listen to this podcast.
This and some others as well, perhaps, yes.
Great. Well, are you ready for today's topic?
Of course.
Good. Welcome everyone to the Clean Industry Podcast. And just like all the other episodes, this episode is brought to you by Hycamite. We're a company that produces clean hydrogen and solid carbon by splitting methane. And in this podcast, we explore the technologies and innovations that shape the future of industrial decarbonization. And this episode is a part of a series called Hydrogen 101. And in this series, we break down the fundamentals of hydrogen, just like what it is, how it's produced, and how it can be used. My name is Sonja, I'm your host, and my co-host Matti Malkamäki is a long-time energy entrepreneur, a visionary in clean tech, and a leading voice in Europe's hydrogen economy. Welcome back, Matti. Today we are diving into a subject that is very close to your heart, and through my work here at Hycamite for the past 2 years, it's become really close to my heart as well. We are going to talk about methane splitting.
Exciting.
Yeah,
It is.
You look excited, like in a Finnish way, excited.
Yes. We look excited, the Finns, I mean.
Well, it's not very obvious, but another Finn can usually spot if a Finnish person is a little bit excited. Firstly, I would like to ask you, because we've heard terms like methane splitting, we hear turquoise hydrogen, and we hear methane pyrolysis. There's all kinds of terminology going on around this specific technology. Could you explain what all of these are and what's the difference? How does it work?
Yeah, I mean, this is a little bit, so to say, weird area in that sense that, first of all, the listeners that have listened to the previous podcasts, they know that I'm not really a big fan of these colors. So that there's all these other green, blue, and so forth, and we just learned that our hydrogen is turquoise. Even though that I also heard that when we are making the turquoise hydrogen from biogas, it should be golden.
Oh yeah, right.
That's something, but it's just, I mean, okay, it is what it is. On the other hand, when we are talking about methane pyrolysis or methane splitting, the pyrolysis as a word describes that you can, break organic material into its elements or into its compounds by using heat without any oxygen being present. In the past, there's been a lot of pyrolysis, oil, tests and so forth, that how you can do it and this kind of stuff. In the methane world, however, there's only few processes that use purely heat for breaking the methane. So there are different kinds of technologies. Like in our case, we are using solid catalysts. You can also use molten metal catalysts. You can use plasma. You can use microwaves combined with a plasma.
And we can get into those technologies.
Yes, we can get into those later. And then there's also the traditional just heat.
Yeah.
But if you are actually precise, then with this terminology that what pyrolysis means, first of all, it's a difficult word. I mean,
for a Finnish person especially.
Yeah, we have heard some different versions of the pyrolysis in the past.
Yeah.
But I think that the methane splitting as a term is better to use, because that actually includes all these different kinds of technologies that what you are and how you are able to split the methane molecule. And it's much better in the layman's terms, so that the normal man of the street, really understands that, okay, you split the methane. And when we have discussed with different kinds of people and politicians and some journalists and so forth, and when we've tried to explain the word methane pyrolysis, it's a lot more difficult to understand if you're not a chemist. And for that reason, methane splitting, when we have used that word, everybody's like, why didn't you tell me in the first hand? So that's why we try to use the methane splitting. So I hope that this clarifies it a bit.
I think it does, and I think you're making a very good point. We do see a lot when we're following this on in media, for example. We can see methane pyrolysis is still used a lot, but methane splitting is something that's more descriptive of this technology. And for the sake of that, I think for the rest of this podcast, we should use the methane splitting as a term. So in very basic terms, how does methane splitting work?
Well, as I mentioned, so that there are different ways for split the methane molecule. But in practical, the methane molecule consists of one carbon atom and 4 atoms of hydrogen. You split them, you separate them, you have the carbon, and in this case, the carbon becomes solid. So it's solid carbon. It's not carbon dioxide, but it's elementary carbon. And then you have hydrogen. So you have 2 hydrogen molecules, 2 times H2.
So if we compare with SMR that we've spoken about earlier with gray hydrogen, in that case, the carbon is carbon dioxide and it's released in the atmosphere. So
Correct.
In the case of methane splitting, it is solid carbon.
Correct.
That makes a huge difference in the CO2 emissions.
That makes a huge difference in that sense, because we don't have any oxygen in our process. So from the process as such, from this reaction, there's no CO2 born. So that you have only the solid carbon and you have only the hydrogen. And what makes then the difference is that, okay, what kind of carbon you are producing. Because the carbon molecule or the carbon molecules, when you have lots of carbon atoms, they can form all different kind of carbons that what we are known to. And they vary from, say, barbecue carbon or coal
Yeah.
that you are putting on the barbecue, all the way up to diamonds. And you have the carbon nanotubes, the nanofibers, you have the graphite, graphene, fullerenes, whatever. I mean, black carbon and so forth. So that is everything included in that carbon. And that makes the difference between the methane splitting processes, that what kind of carbon you are able to do.
So you mentioned some of the different methane splitting technologies, and
Correct.
we'll go into those a bit later. But you said that the carbon quality is something that sets these different technologies apart.
Correct. So most of the methane splitting processes, they produce carbon black. And this is very, very interesting part because, of course, we know that all the carbon, except the diamonds, they are grayish or black. And there are quite a lot of misunderstandings in that sense that people are thinking that the carbon black is just, or black carbon is just, like a main definition for all the carbon that what we can produce, but it is not. Carbon black is dust, practically. I'm speaking here in layman's terms so that how a normal man from the street would understand it. So that when we had those printers, or still do those jet printers where you have the ink inside the printer, so that ink is more or less carbon black. So it's very fine dust, and you need to have that fine dust when you are making, for example, tires or something like that. So it is used as a pigment. So, for example, when you have a laptop that is black, the color comes from the carbon black.
Yeah.
When you have tires that are black, well, they always are, the color comes from the carbon black, and so forth. On top of that one, we can make different kinds of carbon. So we can make, for example, carbon nanofibers, where you have these carbon atoms structured so that they are forming like nanoscale wires, if you will. Then you have carbon nanotubes that are like small tubes that are being produced by or made by the carbon atoms. You have graphene that is one layer of carbon atoms, and when you have many of these layers, like in a box or something like that one, like a nucleus, you have then graphite. So there's all sorts of different kinds of carbon allotropes, if you will, and they are then used in different kind of applications in the industry.
Okay, and can all of these methane splitting technologies produce these types of carbon?
No. The carbon chemistry is very complicated.
Yeah.
I'm not a chemist, as you know, but what I've learned so far is that depending on the way that how you form these carbon molecules, I mean, in which temperature and what kind of process it is, it has an effect that what kind of carbon you are making.
Yeah.
So, for example, when we are also publicly hearing that, for example, companies that are using hot temperature plasma, as an example, they can only make carbon black. So there you have this fine dust that you can use in the tire industry, for example. But in our case, we can make graphitic carbon so that we can then, make battery grade graphite from that carbon that what we are getting from the reactor.
Okay, so now we know what happens on a molecular level in methane splitting. How does it work in industrial scale?
Well, as what we discussed earlier, hydrogen is used for decarbonizing industry.
Yeah.
So it is not something like miracle that you can use elsewhere and so. But in how Hycamite is seeing hydrogen is that you can decarbonize industry. And with the methane splitting, you actually can move the hydrogen production very close to your end customer, whether that is an industrial customer or, a smaller one. There are companies that are, different or say technologies that are different sizes within the methane splitting family.
Yeah.
But in our case, we go for industrial customers. So there's an industrial customer that utilizes now natural gas, and they have the natural gas pipeline or delivery that comes to the site. So that infrastructure is already in place. What you can do with the methane splitting then is that you can go to that customer and you can capture that carbon away from the natural gas. And then as we don't have any CO2 emissions and the customer is using only hydrogen or mixture, but for that part that they are using hydrogen, there's no CO2 emissions. So you can use this technology very, very, very effectively to produce the hydrogen for the customers and then decarbonize the industry in that, or the end users in that sense. And this is really very critical how we differ from all the other hydrogen producing methods.
So you mentioned the infrastructure and using natural gas, and the natural gas infrastructure is already there. What about energy? Does this require more electricity? How does that work?
Well, the process is endothermic. That means that it requires some energy. So that comes from the laws of physics, and we can't avoid that one. But if you compare methane splitting, or especially catalytic methane splitting, to, for example, green hydrogen, where you're splitting the water molecule, we are using a lot less. So, for example, in Hycamite's case, we are only using 1/8 of that energy that the electrolysis processes are needing. And what is even more important is that when electrolyzers need electricity, as the name says, we use heat. So most of our energy need is actually heat. And that is a lot more, cost effective than using the power for the process.
So that heat that's used in the process, can it even be waste heat from other companies or from the same process?
To some extent, yes. So we can use either some waste heat from power generation and so forth, or utilize the heat that they have in their equipment. But it varies from side to side. So in steel industry, yes, you have that kind of temperatures that you could utilize there. But if you go for some low temperature chemical industry where the waste heat might be, below 100 degrees of centigrade, then not really. But in those cases, we can use either the natural gas itself or better, the hydrogen for heating up the process, and that lowers the carbon footprint even more.
So the methane splitting process, it produces hydrogen to decarbonize the industry that would be using natural gas.
Yes.
What about the carbon? Does it have a potential to decarbonize the industries where it's used?
Yes. So there's a lot of regulation on that one, and perhaps we discuss that a little bit later.
Yeah.
But the main principle is that way, that the carbon products that you are getting from methane splitting should be always something that you can utilize. So, of course, you can put that on a ground so that it stays there forever, because it's solid carbon, it will stay. It's not about that. But you can also utilize it in ways for replacing other carbon products, because we are using already a lot of carbon products, elementary carbon products in our day-to-day life.
Yeah.
I already mentioned the pigments, for example, that we are getting, so that the carbon black or the furnace black that we are getting to make these colors, or the black color that we are using, it is being produced for that reason. Now we are getting it as a side stream. And that, of course, helps so that we don't need to go and start mining for that carbon and producing it further. The same in our case when we are making graphite, for example. So we know that the existing graphite production has a carbon footprint of almost 20 kilos of CO2 equivalent per kilogram of graphite. And in our case, we can be well below 5, even below 3 kilos of CO2 equivalent per kilogram of graphite. So that is a huge step further to decarbonize also that part of the industry. So it has a win-win.
It really does have a win-win. Are there any problems with this technology? Because at least a lot of people would say that the use of fossil fuels in this case would be problematic.
We have discussed about this also briefly, earlier, but the problem is really not the fossil fuels per se. The problem for the climate change are the CO2 emissions.
Yeah.
And we use a lot of energy as a mankind. If we want to get rid of that one, then I don't think that's very, very practical choice. But what we can do is that we can start decreasing the CO2 emissions and do that a lot. So methane splitting is indeed a technology where you can do that. You can decrease the CO or deduct the CO2 emissions with a great magnitude very quickly. So that is something that is beneficial, and then you can start moving towards the renewable energies. But you need to understand that also the renewable energies, they have a carbon footprint. And in all of our cases where we have, visited an industrial customer, we have made the life cycle analysis of our emissions using the fossil fuel, the natural gas, and taking even all those upstream emissions into account, and then calculated that what is our CO2 emissions, life cycle emissions for producing that hydrogen to the customer. And when the customer themselves have calculated that what are the green hydrogen emissions, the green hydrogen has always been worse. So there's still a lot to do in decarbonizing the power grid. And before that one has been done, I think that we are the winning technology in this sense.
So you mentioned that we are the winning technology. So methane splitting, especially catalytic methane splitting, is the winning technology in the clean transition. Is that our role? Is that the silver bullet?
Still, there's no silver bullets.
Golden bullet?
So no. I've tried to say it all the time that we need to have, as a mankind, we need to have multiple solutions.
Yeah.
Turquoise hydrogen, methane splitting, how we are doing that at a Hycamite can and will play a very, very big role in that one. But we need to have the others as well. We need to have more, renewable power fed into the grids and so forth. So the electrification is a big thing, and I'm really supporting that one. I've always also said it that way that there's no competition between that whether we should choose between green hydrogen or turquoise hydrogen, for example. But I think that it's rather that way that it is easier for the green hydrogen also to come to the market if you have the base load with something that what we are producing, because we can make hydrogen with large quantities and with a very low carbon footprint. So it is then easier for the green hydrogen producers to start fitting into those pipelines and so forth.
So it's done in steps.
It's always so. You need to climb to the tree from the trunk and not from the top. So
I think we're going to do this in 2 episodes because we have a lot to talk about when it comes to our own technology. I have one question regarding like the entire ecosystem around hydrogen technologies in general. Is there some sort of a supporting technology for us that doesn't exist yet or should be further developed?
Well, first for the ecosystem, so that when we are using this kind of technologies like methane splitting or any other new technology, we can open new frontiers in many ways. And for example, if we are to make here like the CRMA status of the company states that we would make graphite production facility here in Finland, that would mean that we can then lure to that area also other hydrogen producers because we will have excess low carbon hydrogen. So that is part of the ecosystem. But related to new technologies as such, when we established this CSF, we then said it out loud in the publicity that if there's somebody that wants to, test their new technology with hydrogen and so forth, come and knock the door, contact us, and then let's start discussing that what we can do together. And we have this kind of partners and solutions already coming where some new applications are coming, or new components or new materials are being tested and used, and there's a lot of potential. And I'm a big believer of collaboration and ecosystems in that sense.
Yeah, it's been really great to notice what kind of companies are interested in trying our technology.
Correct.
It's yeah, I don't even have the words, and unfortunately we can't be name dropping all of these companies here, but it's been really great.
People will learn.
Yes.
Yes.
Is there anything that has surprised you when it comes to like early adoption of methane splitting for our customers, both for carbon or hydrogen? Has it been
I
welcomed?
think that it's been for sure. I mean, how the customers have taken us and what kind of visitors we are getting, on a weekly basis here in Kokkola, it's a really positive surprise.
Mm-hmm.
So that we are. I don't know whether we should start charging the city for the tourism here, but it is for such a young company. It is a meaningful amount of people that we have. So we had to, as you know, create even our own policies and strategies that how we are handling the visitors. And so I if somebody had asked me 5 years ago that, okay, do you think that we need to start preparing one of our meeting room as a visitor center?
Yeah.
I would have said no. so that is a surprise. But on the other hand, what has come as a bit like a surprise for me is that how difficult it is actually to introduce new technologies to regulatory work, especially here in Europe. So we do have a lot of support from the ISO standards. We do have a lot of support from USA, Canada, for example. But for some reason in Europe, the things are moving slower.
I think that's a good topic for our upcoming episode.
Yes.
We'll dive deeper into the regulation and what that looks like today. Before we wrap up this episode, I would like to ask you, I've been at Hycamite now for a few years, and I've learned a lot about methane splitting and about hydrogen and carbon in general. Could you teach me something that I don't know yet?
Oh, it's a really difficult to say that, okay, what I could teach you, because I don't know that actually what you do know.
You get to test that.
Yeah, I need to test that. I'm just thinking that this is a bad one. Can I come back to this one?
No. Okay, consider this. I'm not an engineer. I'm not a chemist. I've been here for a few years.
But you're a quick learner.
Yeah, that's true though.
That's true. Perhaps we wrap up there.
Okay, fine. You get to think about it until the next episode. And then when we start the next episode, you'll have something new that you can teach me about methane splitting.
Okay, will do.
Agreed. Great. Thank you, Matti, for being my co-host today. Next time we'll continue about methane splitting. And thank you to all of our listeners who've been listening into Hydrogen 101 and the Clean Industry podcast. See you next time.